So today we'll look at the long brief for practice forced landings. So we have now left the circuit area, and now we'll look at how to land the airplane safely in case we had an engine failure. And I'll be shortening practice forced landings to PFL. Some housekeeping before we get started. So because actually this is an online brief, there's no housekeeping required. So aim to discuss and learn the pattern, procedures, and techniques to achieve a safe landing and successful outcome in the event of an engine failure. So we only have one engine on our airplanes, and so in the unlikely event it fails, this brief aims to teach you some of the techniques and procedures you need to adopt in order to have a safe. It is essential to practice and become proficient at the forced landing procedure. It is also essential to develop good decision making using sound judgment to achieve a safe outcome. So this is what aviation is all about being proficient and using good decision making to achieve a safe outcome. And prior planning prevents poor performance. One of the best things in aviation, the more prepared you are for a forced landing scenario, means the best chance you can have of having a safe outcome, which is the ideal outcome for all flights. And you will get at least one practice forced landing maneuver for each of your commercial pilot license test or your recreational pilot license test, and even your private pilot license test. So it's really important you keep practicing them. So an overview of what we'll have a look at. So objectives, that's the take-home message. We'll have a look at revision from our descending brief and circuit emergency brief. We'll look at the definitions that are relevant for today. We'll look at the priorities as well. Reasons, situations, why. It's similar to our circuit emergencies brief. We'll look at the field site election criteria. We'll look at the radio calls as well we need to do in flight. We'll look at the application, at the standard operating procedure for the practice force landing procedure. We'll look at threats. Since we're doing an emergency procedure, there's a few things we need to think about so we don't have a real engine failure. And I'll summarize everything, and then finally I'll ask you a few questions with the objectives. So following this brief, you'll be able to, from memory, state some possible reasons for an engine failure. So this is important because if you know some of the reasons, you can recognize it in flight if you are in one of those scenarios, and then you can immediately carry out the forced landing procedure. This is important, so state the initial actions to be carried out after an engine failure, because you want to know straight away what you need to do in order to have successfully restart the engine or continue on with the forced landing procedure. State the methods for determining wind direction. We want to be able to determine what direction the wind is coming from. We want to land in a headwind, so that's really important as well. What checks do we use to determine a suitable field? So we'll have a look at something called the WAS checks, which helps us determine if a field is suitable to land on. And then identify and manage 2 airborne threats, which we'll have a look at all throughout this brief. So revision. So you can take a moment, pause this video, so then you can answer these questions. But I'll read the answers out now. What is the effect of flap extension on glide range and on our aim point? So it decreases our glide range and brings our aim point forward, our aim point back, so that we can land at the start of the field. Relevant because in this lesson, if we're too high, we can use flaps to decrease our gliding range, or simply, if we've got the aim point a third in the field, we can use flaps to bring it towards the start of the field. What controls airspeed when the engine fails? So power or attitude? Well, since we've got no power, our engine has failed, our attitude controls our airspeed. So that's really important. It's just reiterating the pilot's lift formula. What is the speed for best glide in the PA-28 Orion? It's 73 knots. So this is really important because this is the speed we need to maintain. It's the minimum drag speed and gives us the best range. What are the emergency shutdown checks? So it's FMMM, fuel off, mixture, mags, master, switches all off. So important because in this lesson we'll be doing touch checks as well, and you'll shut down the engine also if you had a fire. But it's really important these are touch checks only. Now we've got that threat of low speed flight. The aero will be exceeding critical angle, and the undesired aircraft state will be a stall. So make sure you maintain glide. The international radio telephony distress signal, when repeated 3 times, indicates grave and imminent danger and that immediate assistance is required. Poundback call, the international radio telephony urgency signal. It is used when there is an urgent situation of a lower order than a grave and imminent threat. So in this lesson, we'll be looking at the Mayday call, and the Poundback call is usually used for If there's a medical emergency, if you're doing a precautionary search and landing, you found stranded people in the area. And it's really important you know how to do a Mayday call and also a pan call in case you need to make one, so that you can give ATC the appropriate info and they can give you the help you need. So in the training area, we won't actually be delivering the call to air traffic control. We'll just be delivering over the intercom. So key points. These are specific points used in the PFL pattern for performance and for aspect assessment. And we've got high key, which is approximately 1 kilometre upwind of the aim point on the landing area and the landing field at 2,500 feet, and low key, abeam the point at 1,500 feet AGL. So since in the training area we've got different elevations, so at 300 feet AGL, so it'll be 2,800 feet our high key, and our low key will be 1,800 feet, as you can see in the diagram. And our aim point is a third into the field, and the common aspect with a high and low key is that they are all relation to our aim point. So you must choose your aim point first, then your low key and your high key. And we usually start our PFL pattern a little bit higher than a high key, but in a real situation, the engine could fail at any height. And this lesson, we're going out to a predetermined field, but also watch out for traffic in the training area because it's quite a common field. The area will be having a poor lookout due to high workload, and the undesigned aircraft state will be an air proximity event. So make sure you maintain lookout and use a lap cycle. So priorities, you must aviate, navigate, communicate. So, whether you are doing a go around, whether you're in a navigational exercise or when you're doing a PFL. Aviate, you are in command. Fly the aeroplane to prevent the undesired aircraft state, so you must control the aeroplane first. Navigate, consider your options, obstacles, terrain, population. Do you have time? Is there a nearby airport you can glide to, or do you have to land immediately in a nearby field? Communicate with Mayday call / doing a passenger brief. And communicate so others can help, even if it is to stay out of your way. So reasons and situations why. So an engine will rarely fail instantly. It will most likely have cuff or have rough running. So some of the reasons are fuel starvation, fuel exhaustion. So fuel starvation, there's fuel but it can't reach the engine. Fuel exhaustion means we've simply run out of fuel. There's no more fuel left at all. Insufficient oil quantity will be an oil leak. Mechanical failure in terms of each of the engines and its components. There could be carburetor icing, which can lead to that fuel starvation. Blocked fuel vent. There could be engine fire, airframe damage from a bird strike, or a control failure as well. And a lot of these issues can be prevented by having a good, thorough pre-flight. So we've got that threat of a poor time management in the system. There will be not doing good, thorough pre-flight, and the undesired aircraft state will be engine failure. So make sure you have a good, proper pre-flight for all lessons. Glide distance, so anything other than the optimal indicated airspeed will decrease our glide range. So we looked at this in our descending brief at the best indicated glide speed, 73 knots, gives us the best range, and anything faster means we've got a lot of parasite drag, anything slower means we've got a lot of induced drag. Never attempt to stretch a glide. It does not work. You've got a high nose attitude, and it looks like you're actually making it looks like you're making the field, but you're not. You're actually having a steeper approach. So even if you're undershooting the field, there's nothing you can do but maintain the glide speed. You must maintain it at all times, 73 knots. In a real emergency, it does not matter where you land, as long as you land safely. Be it a private field, be it an airport, an active runway, or a grass strip or a paddock. The glide range of the Cherokees is 12 to 1, meaning per 1,000 feet in height we lose, we can glide 12,000 feet, 2 nautical miles. So we looked at this in descending. So at 1,000 feet we have a 2 nautical mile range, and at 4,000 feet we have 8 nautical mile range. So if you have a rate of descent of 700 feet per minute, this gives us more than 5 minutes at 4,000 feet. So just with these dot points, that's why it's really important to fly as high as possible. The higher you have, the more fields you have available to glide to. And in a realistic scenario, of having 5 minutes left, that's plenty of time, providing you use it wisely. Field selection, rule of thumb, look down from your window at a 45-degree angle to consider potential spots you can glide to. And it's sort of like in a conical shape, just like this sort of image. And these methods allow us to determine a suitable field to land on in the training area. So rock the wings around to spot an appropriate landing area. There could be a field to your right, but a left circuit pattern is preferable. This is because the pilot command usually sits in left, you sit on the left, and it means you can have the field in sight at all times. We're going out to a predetermined field. It won't happen in real life, so always be thinking of a plan B of a field you can land on, so that if you do have an engine failure, you can waste no time and head there straight away. So field selection is done using our WASP criteria, so wind, overshoot, undershoot, surroundings, size, shape, slope, and surface. These checks are done to determine the suitability of the field for landing. So wind. How does wind affect our gliding distance? So tailwind means we'll glide further, but a headwind reduces our gliding distance. But we want to land into wind. So the PFL pattern allows us to use tailwind for the downwind leg, and then once we're at our low key, we turn around and we land into wind. And I'll show you as well what it looks like in a moment. So first off, ascertain where the wind is coming from. So you can use weather at the aerodrome, so information such as the ATIS, the TAF as well. You can use the drift of the aeroplane. So the drift, so if you on a navigational exercise, you can know where the wind is coming from, and you can land into wind straight away. And environmental factors as well, which I'll show you as well. So we've got known surface wind, so using that windsock before takeoff. We've got grass, if it's long grass, it can tell you the direction of the wind. Smoke from fires and dust is really good because it tells us not only the direction, but the wind strength. And wind lanes adjacent on the water, so as you can see it's going diagonally. You can see the ripple effect it has on the water, so the wind is sort of flowing diagonally. And in the training area, I'll show you a few indications as well, if there are indications. Another thing with water as well, if it's perfectly still, that means there's light or variable or even no wind present, so that's important. It means we can land in any direction. Overshoot / undershoot checks for obstacles. Undershoot's what you can eat, such as a fence, it could be power line, and it's really important to maintain your glide speed so that you don't undershoot. And overshoot's what's in front of you, so it could be trees, a fence, or a ditch. Surroundings, obstacles in the area, trees, population, roads, water. So surroundings that are desirable to land on, and surroundings you may need to avoid. So if you had an engine failure somewhere remote, you would want to land as close to a road as possible so you can get new civilization and you can get the help you need. Size, 500 meters length or the longest available. So it needs to be this long as it is sufficient enough for us to land and come to a complete stop. It's about half the length of a runway at Bankstown Airport in Sydney, but it can be hard to judge, so just use a rough estimate. And you can land diagonally as well if it means there is a headwind. Shape, ideally a rectangular field or a strip of land. So a rectangular field is good appropriate length and is almost like landing on an actual runway. Avoid circular fields, as you may be able to land in any direction. However, there could be crops, long and tall crops growing. There could be irrigation machinery as well, which you would want to avoid. Slope, up, down, / level with reference to landing direction. So from our circuit brief, we want to land in the upslope. However, there's a few illusions with landing upslope in terms of flaring, too early or too late. So make sure you choose a level field. And it can be quite tricky to judge, but water flows downhill, so you can judge the slope using that. But yeah, aim to land on a level field as we're used to landing in terms of runways. Surface, rough, smooth, long / wet grass and livestock. So short dry grass is best. Some grass strips are like this and most likely to support the aeroplane weight. Avoid long grass as you cannot see any ditches and you cannot judge the surface as it may not be able to support the aeroplane weight. So here we've got a map of the Bankstown training area, quite a common field we can use for practice. So if the wind's coming from the northeast, we'll be landing into the northeast, sort of this direction. Overshoots, undershoots. You've got a group of trees and some trees here at the end. Surface is short dry grass. Shape is, yeah, if you land diagonally, it's kind of rectangular. Slope is relatively level. I've flown over this field. I know what the slope is. Surface, shape, slope, size is sufficient, more than 500 meters, and surroundings. We've got a few rocks and trees we need to. So, distress call, Mayday. So it's from the French word "Mayday," meaning "come and help me," and used when in grave and imminent danger. So in the PFL scenario, so the structure is Mayday, Mayday, Mayday. 5 Ws. Who you're talking to, who you are, where you are, what is wrong, and what your intentions are. So for example, Sydney Centre, Cherokee. Mayday, Mayday. So distress call, Mayday, from the French word "Mayday," meaning "come and help me." So used when in grave and imminent danger, and the structure is Mayday, 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 5 Ws. So who you're talking to, who you are, where you are, what is wrong, and what your intentions are. So Mayday, 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 City Centre, Cherokee, Alpha Bravo Charlie, 15 North miles west of Bankstown Airport, 2 PAB. We've had an engine failure, and we're doing forced landing and doing an immediate landing as well. And the structure is in the URSA, so if you want, you can look up the structure of it as well, and we'll be practicing the radio call over the intercom. So application. So PFL is all about developing a plan, but don't be afraid to change it depending on the situation. Checks are only there if time permits. You'd rather make the field and have done none of the checks than do all the checks but not make the field. And an engine can fail at any height. So that's why it's really important to always be looking for plan B and always aim to fly as high as possible. So if the engine does fail, you've got a lot of time. So we've got the threat lesson of fuel exhaustion, the error will be poor fuel management, and the underlying aircraft set will be reinforced. So make sure you monitor fuel and you change tanks. So PFL standard procedure. So it will start off with multiple simulating engine failure. But a few things before, we'll keep the field in sight at all times. So that's why we'll do a left-hand pattern. And I'll talk about the field. We'll look at the wind direction, the WASP checks, high and low key. And we'll start off about 3,500 feet. So it gives us 1,000 feet high key, 1,000 feet to low key, and 1,000 feet to a go-around height. And so yeah, we'll start with my throttle simulating engine failure. If you don't hear simulate, assume real engine failure is occurring. Then you're going to control the airplane, establish glide speed 33 knots, and trim. Aviate. Trim so you can focus your attention on flying the airplane and various checks. A-lab, you want to look outside, look out for traffic, determine the performance, and monitor. And then you'll check fire or failure. So if it's an engine fire, you're not going to do the restart checks as you're adding fuel to the fire. You do the shutdown checks, but it will be just a touch check only if you're simulating it. And then we're going to do the initial action. So glide speed 33 knots, carburetor heat on. Maybe there's icing, mixture fully rich, fuel pump on. Maybe the engine-driven pump failed. Fuel selector switch to tank containing fuel. And if power is restored, carburetor heat off and fuel pump off and check pressure. Power is not restored, proceed with the powered off landing. So we'll assume that's simulated, we'll continue. So now we're going to do, you want to select your high key, low key, and your WASP checks. So you've already ascertained the wind direction, we talked about it. And then we're going to do our field selection. So our WASP criteria, wind, overshoot, surface, shape, slope, size, surrounding. Now you must select your high key and low key and your aim point. Make sure you choose good physical features around the point so that you know when you reach the point and what height you are, and whether you're too high, too low, or at the right height. And then you're going to lower the nose in turns to maintain the glide speed. So remember, for our turning brief, we have a little bit of drag, so we have to lower the nose a bit. So then we're going to continue along to the downwind leg. So we're going to do our troubleshoot checks, CF most checks. So carburetor heat set. Maybe the linkage is a bogey. Mixture of fuel quantity and shut-off valve check. Have you got sufficient fuel? Have you accidentally shut the fuel valve off? Mixture operate through the range. Remember, these are touch checks only. Is there a ratio that will get the engine restarted? Oil T's and P's check. If no fuel pressure indicated, check tank selector position to ensure tank contains fuel. Switches mags left, right, both. Maybe there's one mag that'll work. Throttle operate through the range and set half an inch open so that if the engine does restart, it'll let us know. And then you're going to do spacing, so you want that 1/3 wing spacing, so you're within gliding distance at all times. Then you're going to warm the engine. So remember, we've got that threat of low power ops. There will be not managing engine, and desired aircraft state will be engine damage. So make sure you use carb heat and warm the engine. You're going to warm it to 2,000 RPM for 4 seconds every 1,000 feet you descend. Then you're going to do throw TEM. So just like the threat and error management, we'll do transponder 7700. So you're not actually going to put it; it's just a touch check. ELT on, Mayday call as well. Passenger brief, so include as much information or as little information depending on time. So for example, we've had an engine failure, we landed field on left. Please start with loose items, assume the brace position. After landing, mix towards the right, something well right off there. Then you've got to be at your location. Then at this point, you're going to do the 50-cent pattern. Remember, it's going to be almost kind of like a glide approach. And your checks are done, so you can focus on flying the airplane. So it'll be that 50-cent pattern, where you're assessing that spacing with the wings level, and the aim point should be within that 1/3 spacing, so that you can reach the field. And if the aim point is getting farther and farther towards the wingtip, then turn towards your aim point. If it's getting too close, level the wings. And also use aim point, airspeed, aspect. So aim point 1/3 in field, airspeed 73 knots, and aspect judging if you're too high, too low. Then once you're sure you can make your field, bring the aim point back using flaps. Then you've got to do shutdown checks. So these are touch checks to FMM. And it'll be a short field landing as well if you were to do it. And fire and feet go around. You must do a go around. Remember, it's not a student initiated go around. It is a student initiated go around. So the instructor must not prompt you. So that's really important. So importance of high key and low key. So high and low key are used as target heights to aid and assess the progression within the pattern in order to give us the best chance of making the field. It tells us if we're high or low approach and allows us to adjust our flight path as required. The secret to a good forced landing procedure is selecting a high and low key and knowing your height when you reach those keys, whether you're too high, too low, or at the correct height. So if you're high key, extend your crosswind leg slightly, but do not lose sight of the field. If you're low at low key, head straight for your low key and maintain glide speed. And if you're too high at your low key, extend your downwind leg slightly, widen the base turn, use flaps. But if you're too low at your low key, head straight for the 1/3 aim point and make sure to maintain that glide speed. So airmanship, look out as you could be fixated on tasks when you're going out to a common field in the training area. So make sure you have a good, effective lookout for other aircraft. Go around obstacles / terrain, noise abatement. So aim to do your PFL in a unpopulated area. Minimum altitudes, so elevation in the training area. So it's 1,300 feet for popular area and 800 feet for non-popular. So make sure you don't go below those levels, those heights. Engine considerations, point and response. So make sure you apply carb heat. Don't forget to turn off when you're doing go around and make sure to warm the engine. Accurate flying. Make sure you set the attitude, get that 73 knots, and you monitor your 1/3 wing spacing. So aviate, navigate, communicate. So threat and error management, we've already looked at a few threats, errors and management techniques in this lesson. So threat of low speed flight, the error will be too slow exceeding critical angle, and the undesired aircraft state will be a stall. So you'd manage this by maintaining glide speed. We've got the threat of low power ops, the error will be not managing engine, use carb heat, warm engine every 1,000 feet, the undesired aircraft state will be a loss of engine power. We've got the threat of traffic, maintain lookout is a management technique, and the undesired aircraft state is airpoxy event. So the error will be poor lookout due to the high workload. And then finally, real engine failure, poor fuel management, poor engine handling, fuel monitoring, and the undesired aircraft state will be a real force failure. So there's 4 threats here. It's certainly not limited to these 4 threats in this lesson. There's a lot more that exist. So make sure you're aware of them and you prevent it from reaching that undesired aircraft state. So in terms of revision, we looked at revision from a descending circuit brief. We looked at definitions such as Mayday, pan, high and low key. We looked at the priorities, aviate, navigate, communicate. We looked at a few reasons and situations why. Look at the criteria for the field selection. Then the radio call, so the structure of the Mayday call. the application, so make sure you know that section really well, because that's what we'll be practicing in the flight. Look at the airmanship and threat management consideration, so the threats exist, how you can mitigate the risks, and in terms of threats, we look at traffic, minimum altitudes, warming the engine, monitoring fuel, and make sure you do PFL, aim to do it over a non-populated area, just that noise abatement, and so we can go around 800 feet instead of 1300 feet. And then finally, the objectives. So from memory, state 2 possible reasons for an engine failure. So if you want, you can pause the video and then you can come up with answers. So 2 reasons are still fuel starvation and or fuel exhaustion. Select the initial actions to be carried out in the event of a complete engine failure. So glide speed 33 knots, carbon mixture fluid, fuel pump on, or your CMF checks. Select the methods for determining wind direction. So you've got grass, clouds, water, the ATIS. Then what checks do we use to determine suitable field? So the WASP checks. So thank you all so much for listening to this brief, and I'll see you in the next one.